something known as natural language processing. So we call it NLP as in short. Now, when we talk about this term called NLP or natural language processing, we are looking forward to get something out of textual content, right? So natural language processing is where we are trying to work on something known as unstructured data. So as of now, the data sets on which you are working, they were structured. Now, when I say structured, what exactly it means, right? It means that you have this comma separated values, you have this tabular format, you have the databases where the data is quite structured, right, in the form of your object here and there. But the world is unstructured somehow. So only 20% of the data is structured, rest 80% is unstructured available in the world. Now, for an instance, when someone is posting a review or a feedback, right, or when you're writing these messages in WhatsApp, so they are not structured, right? They are unstructured. These are the text messages. So you are putting up the data on Messenger, on messages, you're putting up some comments and reviews and likes, right? So the data is unstructured. It's all textual content, right? So how we should be discriminating between this structured and unstructured data? When we talk about structured data, it is organized. When I say organized, for example, an object, right? Attributes, dictionaries, key value pairs, or CSV files. So we got the data in a structured format. When we talk about the unstructured data, now whatever we are speaking as of now, right? Whatever I'm interacting with you guys, so this data is unstructured. The text especially is unstructured. The tweets on the Twitter are unstructured. The messages which you send on WhatsApp, right, and various other things in the form of textual exchange is quite unstructured. So the world has a lot of data which is unstructured, and unstructured data cannot be used by the ML models to do some predictions or other stuff. So in the natural language processing, this itself is a part of computer science, right? And it's a subject with respect to AI. Of course, it is going to be dealing with human languages first. So NLP for us is something known as a separate subject. You need to understand it's a separate subject in itself. So AI is separate part, machine learning is separate, right? Computer science, algorithms, data structures, languages are separate. NLP is a separate technology, right? So this session is all about how you guys can actually work on natural language processing and how you guys can actually kind of deal with it. So let us see the next part here. So the natural language processing is for significant and actionable insights from unstructured textual data. So we are trying to get some insights from unstructured textual data. It is important that we should know what are the techniques and principles associated with NLP. So it's a branch of data science where systematic process for analyzing, understanding, and extracting the information from the textual content in a smart and an efficient manner, right? It's gonna be a separate field of science for us. So where and all NLP can be implemented? What are the various applications? So typically automatic summarization, machine translation, there can be named entity recognition, right? So I'm going to give you an assignment on this NER, name entity recognition today. For example, we are speaking that let's have a chat on Monday. When I'm sending these messages to you guys in WhatsApp groups, right? Let's have the session on this date, postponed to 10:30 a.m. If you will see your WhatsApp messages, right, when I just send this message, right, then we can have the session at 10:30 a.m. So automatically WhatsApp will highlight that 10:30 a.m. the time, right? So named entity recognition is the kind of application of NLP where in the textual content we are understanding what is the name, what is the place, what is the time. So you're trying to understand the entities from the textual data. Then there may be relationships. So NLP is all about, in case you have good knowledge on English as language, right? I'm not saying programming language, I'm saying English as language. You know what are adverbs, you know what are adjectives, etc., etc. You should have a command over your grammatical part of your language English, right? Or if you are trying to do analysis in Hindi or in Punjabi or in any other native language, so you need to have a good hold on the grammatical and the vocabulary part of your language. So in the relationship extraction, let's say we are exchanging messages on WhatsApp. So to derive who different kind of people are interacting to each other, what can be the various relationship between their messages with respect to shopping, with respect to let's say a tour or a trip or a planning, right? So companies like WhatsApp, right, they have a lot of unstructured data, and there are so many companies who are working on WhatsApp data with respect to this natural language processing itself. Sentiment analysis, then of course the speech recognition, when we give commands to Siri or to Google, right? So we even kind of saw how we can work on dialogue flow, how we can write a chatbot. So chatbot is one of the beautiful applications of natural language processing. Then there may be some topics which you can segment. So NLP will have a few terms, introduced to you people for your better understanding on this subject, right? There are few terms which you should be knowing. The first term is tokenization. So tokenization is one process where your text is converted into tokens. Now, when I say a token, token represents a word. For example, I'm saying this is a good day. It's a textual sentence. Now, every single word in this textual sentence can be referred to as a token. So a text object may be a sentence or a phrase or a word or an article itself, right? So we consider the textual content, the entire content, maybe a sentence, phrase, word, article, essay, etc., as a text object, right? So these are the three major terms which are used when it comes to your natural language processing. Now, moving further, so what exactly is meant by tokenization? So there is a sentence, right? We break the sentence into the words. So thereafter, for your analysis, you need to understand importance of each word with respect to that sentence, and then you need to produce a structural description of your input sentence, right? So that's like tokenization. Now let's see how the tokens should work, right? So for example, tokenization is the first step in NLP. So we have broken down your sentence into the words, and they are referred to as tokens. Now, the next thing is text pre-processing. So this is where we're gonna work today on, right? Even we're gonna write some program on the pre-processing of the text. So you have the text. Now, whatever the text you have is quite unstructured. Let's take a reference that you're going to hit a URL and you want to do some web scraping, right? In this web scraping part, what you will be doing is you will be getting a lot of HTML content. Now, there's a lot of HTML content which you are retrieving from a web page is what is unstructured data or text, right? So if you want to implement natural language processing algorithms, or you want to work on NLP, you need to first of all pre-process this data. So pre-processing of the data means what, right? Cleaning the data from the noise. So what can be the noise, right? Now, for an example, there may be some URLs which you don't want to analyze. There may be some HTML tags which you don't care about, right? So these are noises available in your data. Let me show you. Let me show you with an example what I'm talking about, the noise, right? So coming here, let's write one small program and try to see what is a noise. So I'm gonna write this new Python file, session number 52. Let the indexing finish. So just give me a moment. So let's write a new Python file. This goes like session number 52. So this is going to be our natural language processing session. So I'm gonna import our old library called requests. So let us have some yeah. So in order to come up and do the web scraping, I'll say from BS4, let us import the beautiful soup. Let's take some URL to analyze, right? So what I'm gonna do is I'm gonna go to this Google here, and I will open the about page of the Google, right? So let's see what Google says. Google says our mission is to organize the world's information and make it universally accessible and useful. So stay safe. So let's come here and have this URL, right? So what we're gonna do is we're gonna read this URL, and we're gonna get the HTML content out of this URL, right? So I'll say response is your request dot get the data from the URL, right? So you get the HTML content, and I'm gonna print this response dot text. So when you print this response dot text, so this is your entire HTML program, right? Which we retrieved from this web page. The server returned us this web content, and we are just having this as a textual representation. Now, I don't care about this tag head. I don't care about this meta char set UTF-8. But yes, I do care about this about Google, our culture, and company news. I care about stay up to date with Google company news and products. So this is the content, but this is unstructured content for me. And at the same time, right, these all tags link href to style sheets or the fonts, they are noise for us in the data. So can I get an acknowledgement here? So what is meant by noise? So this is the text which is available, but I need to pre-process the text, right? So the text which I want to pre-process is all this, kind of part here in our natural language processing. So I hope you understood what is meant by text pre-processing, why we want to pre-process our textual content. So let's come here back to our presentation. So textual pre-processing is an important task which involves three different steps. So all of the three steps are meant to remove the noise from your text. So when I say noise, it means any unuseful information in your textual content should be removed by you, right? So as a developer, I need to come up and see what and all I don't need. So noise removal, then lexicon normalization, then object standardization. So these are the three different you can say techniques and steps which you can implement to pre-process your text, and then you do your NLP. So you have a raw text or a data set. So you're gonna implement noise removal, then you're gonna implement lexicon normalization, then you implement object standardization, and finally you get this clean text. So you have these layers that how you're gonna work on them, right? So you need to work on these layers. So let's see the next part here for our discussion. What is meant by lexicon normalization? So this, sorry, my bad. So let us first of all see what is noise removal. Now, any piece of text not relevant to the context of data which we want to analyze, or we want to kind of do some ML or AI or deep learning, etc., anything here and there. So you need to end this noise. For example, the commonly used words in a language is am, are, the, of, in. Now, these are the kind of words we call them the stop words, right? Stop words are not useful for us to analyze the content, right? They make a meaning, they may make a meaning to understand that how the relationships are getting, constructed between two different people. For example, right, I am your elder brother, so am is important for us at that time. So you need to very significantly work on when you don't need the stop words, when you consider the stop words as noise, and when you don't consider them as noise. There may be URLs or links, so there may be some hashtags, right? Some punctuations, some industrial specific words. Moving ahead, there may be some slangs available. Nowadays, we have so many slangs available. For example, you got BRB, be right back. So this step is to deal with the different types of noises and removing the same, right? So let me show you one small program. So how we can actually work on noise removal. So I'm going to write a program, and we'll see how we can work on noise removal. So this I'm going to comment. So we'll use this program later, right? I'm just going to take it down. So I'll define a function called remove noise from data, right? So I'll take some text as input from which you want to remove noise, right? But for my noise, I'm going to have a list of stop words. So there's a list of stop words. So we saw that we have is, am, let's say are, the, and there may be a stop word like people sometimes write these triple dots, right? So there's a list of some stop words. So it's up to you. Now in my input here, right? So I'm gonna come up and say that there is a text, right? So I'm gonna say I am really happy and we are going to a vacation, right? So let us come up here and try to sort of solve this problem. For example, I can even include this guy called 2. I don't need this 2. I don't need this guy called right? So these are the list of stop words which I have created. So what I want is noise free text, which I will be obtaining by executing remove noise from, let us take it as text only. Remove noise from text. I'm going to write this function called remove noise from text, and I'm going to take input as text, right? And let's print this noise free text. Now I need to write an algorithm where remove noise from text should work. So let us see how we should work now. So I'll write my Python program only. So first of all, let us take all the words, which is going to be your text dot split, right? So the moment you say text dot split, let us say print the words. I'm just gonna run the program. So what you see is I am really happy and we are going to a vacation, right? So I got list of all the words. So it splitted the data on the basis of space by default for us, right? Now next is what? So let us write one small part here. So this is like your noise free words. So guys, I'm going to come up and create this list here. So it goes like some word for word in words. If word not in your stop words. So can I get one acknowledgement, guys? Is this list comprehension clear to everyone? I'll just print this noise free words. So I really happy and we going vacation. So what you see is am is removed, right? And R is removed. Let us see A is removed. I'm also gonna come up and put some more data. Let's say and. So and is also removed, right? So we wrote a very basic program that how we can remove your stop words. So what I will do next is I will create some this noise free text which is going to be uh, let's say space dot join, and I'm gonna put these noise free words in it, and then I'm gonna return back this noise free text. So now let's see what is noise free text here for us. So I really happy we going vacation. So even if you are going to include this guy called we here and then run this program, so I really happy going vacation. Put this I as a stopper here, run the program. So it's up to you, right? So I'm not saying okay, so this is one more challenge for us, right? So uppercase and lowercase. So you can anytime make sure that your words they can be validated with the lowercase or uppercase. It's all up to you. So can I get a smiley from once again from all of you? So I think this basic program on how we can work with noise removal is clear to everyone. One basic program, right? This is your text pre-processing, and we call this as noise removal. So same way we have one more algorithm on which we can work, right? So you can work on regular expressions. I hope you can recall we even did some regular expressions in our Python content. So I'm gonna use few of those part. So I'm gonna say define remove noise uh, from text with regex, right? So once again, so for this guy I'm gonna take two inputs. One is the text, one is what is your regular expression. So I'm gonna take two of the inputs here. So regular expression pattern as input and your text as input, right? So considering this part here, that we wanna come up and write a program where we can kind of remove the data from your regular using regular expression from the text. So let us define first of all some textual sentence. So there is some sentence here. So stay at home hash COVID-19. So this is one of the sentence, right? So you want to ignore some hash codes, right? So let's say you want to ignore kind of a hash code. So I'm going to create a regular expression pattern. So this regular expression pattern goes like anything starting from hash and it should be a word, right? And you should consider all the characters in the word, right? So I got a regular expression written here. So what I'm looking forward is, so I'm looking forward for noise free text. So this is the text, right? Let's use the same terminology. So noise free text is going to be remove the noise free text with regular expression. This is my text and this is my regular expression pattern. I'm gonna use the same terminology for you guys. So this can be one more way how you can consider removing your data, because when I'm saying noise the removal, so it means that you are removing some data from your textual content. So there may be different ways. So let us write a variable called matches. So I'm gonna say regular expression. So let us import this module, right? So I'm just gonna come here and say import regular expression, right? So regular expression dot find the uh, patterns in the iterable, right? So in the list, right? So list is an iterable. So I'm gonna give the regular expression pattern first and then the text. So let's come here and say print me matches. So we got this regular expression imported, and thereafter we have this remove noise from the text with regular expression. So I've executed this function itself. So for the time being, I'll say print me the noise free text, but as of now, this will be shown as none. Okay. Okay, so let's run the program. So what is matches, right? Matches for me is this callable iterator object. It means you can iterate in this guy, right? So how I will iterate? So I will say for match in matches. This is how you iterate. So let us say print me a match, right? So this guy is object called callable underscore iterator. So it's all Python which you are doing now, right? So when I am printing the match, right, it is printing me that there is a regular expression match, and match is found for this COVID-19. So instead of saying match, you can say match dot group. So when you say match dot group, you will be able to get that word, right, which matched. Now what next I'm going to do is I'm going to come up here and say that your, just give me a moment here. This was a for loop to make you guys understand what we did. So with the regular expression, I'm going to substitute this match dot group, right? That's the word which you found. I'll even do a strip on it, so in case there is any spaces here and there with empty space. So you substitute, right, match dot group strip, substitute with an empty space, but in what, right? I want to substitute this in your text. So this text itself is going to be substituted with this part. And once we are done with this program here, so in the end you can say return the text. So when you run the program now, so stay, okay, so I think this is not substituted. Something went wrong here. We're printing this noise free text, it came out in the same manner for us. Just give me a moment. So this should have been somehow filtered off. Let me just quickly run through this algorithm once. Just give me a moment.
This conference will now be recorded.
So guys, I think this is the problem here. So when I'll do a substitution, right? So I'll get back the text, right? So a new text, so old text will not be modified, rather a new text will be returned back to me. So let me now try to give a run on this. Yes, so here we are, right? So you can now see, right, that the hashtag is eliminated from the sentence. So can I get an acknowledgement from all of you? Are we good to go till here? The noise removal, I've just shown you two different ways how you can work on noise removal. Either you can work with a basic algorithm, you can have the stop words, or instead you can make your regular expression patterns and you can also work on the noise removal part. So let us now come back to the presentation and see what's the next part for us. The next part for us is to understand what is meant by lexical normalization. So there is one more type of noise which is all about multiple representations of the same single word. So somewhere in your textual data you got this play, player, played, plays, playing, right? So this is like the different variations for the same word play, and we would like to come up and remove all these different combinations, but we would just like to focus on the word play, right? So lexical normalization practices are basically divided into two categories. The first one is stemming. So stemming will strip your suffixes. For example, you got this ing, ly, es, s, etc. in your words. So we're gonna eliminate the kind of these suffixes. Whereas lemmatization is a step-by-step procedure where the root of the word is obtained, and lemmatization algorithm is gonna use the vocabulary of a language, right? That's like some dictionary of words and some grammatical relationships between these words at the same time. So stemming is to remove some suffixes, whereas lemmatization is to reach up to a word root. For example, in the above discussion, play, player, played, plays, playing, we would like to come up and get this word called play, right? Or let's say you have this multiply, multiplication, multiplying. So you are trying to get the word multiply. So can I get one acknowledgement here? Is stemming and lemmatization clear to everyone? So this is your lexicon normalization, right? So what happens in the stemming? So we are going to normalize the words into the base form or the root form. And when it comes to the lemmatization, right, we're gonna map this word gone to, going and went. We need to come up and have this as go, right? So different, groups of words which have the relationships to each other. But in order to understand this lemmatization and stemming, we will be not writing the algorithms for us, right? We're not going to work on algorithms. So what I'm gonna do is I'm gonna write this import NLTK, natural language toolkit. So let us open this NLTK. So natural language toolkit is something which you guys should be following. So I'm just going to open the book directly. So this is the link which I'm going to share with all of you. So these are the kind of chapters in the natural language toolkit, right? So NLTK, you need to come up and import. Once you import NLTK, guys, you can even come up and say NLTK dot download. So this download function is going to open a GUI. Let's see that. So when you say NLTK.download, so what you'll see is this GUI coming up for us. So here is this GUI, and you need to come up and make sure that your packages are installed here, right? So you can go to all packages and you can install them. So they are not of that big size here for us, but at the same time, yes, there are a lot of them. There are a lot of them. So we can even skip few of them which you don't need. But this is like entire NLTK which you are downloading in your system. It's nearly 2 to 3 GB overall. Okay. So other than this, whatever the module from NLTK you want to download in your system, you can mention. For example, I can mention this stop words, right? So NLTK.download stop words. So this guy will go and check and see that if it is there or not, right? It says package stop words is already up to date. Let me show you where it is downloading this data. So you see this NLTK data, right? And you have these tokenizer, stemmers, models, grammars, chunkers. So you have this entire data for your NLTK library. So NLTK is the module just like your sklearn. It's a library which you have to use in your natural language processing. So I'm going to show you how NLTK can work with your stemming and lemmatization, right? So let me just put this as one comment. So this is just for one time downloading with GUI, and this is with command. So I have already downloaded the data, right? So I will not be coming up and doing it again. So we are going to understand what is meant by stemming first of all, right? So now I am doing this second step for us in the text pre-processing. So guys, we are working on something known as lexicon normalization, which can be done through stemming and lemmatization, right? So let us see how it can be done. So in order to use stemming, I'm gonna come here and write one import statement. So from natural language toolkit dot stem dot porter import porter stemmer. So this is the class which is going to do stemming for us, right? I'm going to come here and say, let's say stem is a porter stemmer. So you create this object of porter stemmer. Now there is a word which is races, right? So I'm gonna come here and say print me stem dot stem the word. So let's see what happens with this guy called races, right? So guys, when I'm talking about stemming, it's an algorithm. It's a vocab based algorithm, right? You can just dry run and see what this algorithm is and how it's gonna work on Google. So what you see is for the races, this guy gave us the word called race, right? So we are trying to eliminate or convert your words into the roots basically. So this is known as lexical normalization. Let us take another example of your lemmatization. So you are from NLTK dot, we got the same guy called stem, but this time this is wordnet. I'm going to import this guy called wordnet lemmatizer. So this is the API, right? So let's say lem is your wordnet lemmatizer. Now I'm going to take this word, which is, let's say, I will take this word as playing, right? So you say print me lemmatizer dot lemmatize the word playing. So let's run this program and see how lemmatization will work for us. Okay, I think it didn't work for us in a better way. So let me take some another word. I think it's YING. It's gonna take in a better way. It should work. Okay, so I'm just gonna come here and okay, word and POS is by default nouns. So I'm just gonna take it to as V as in verb. Let's try to run the code now. So here we are, guys, right? Now I think makes a sense for us. So by default, it was considering nouns, right? Not the other part of the grammatical portion. So here we are, how we can work with lemmatization. So can I get a smiley as an acknowledgement from all of you? Are we good to go with the very quick introduction to NLTK as well? So this I'm just going to put as a reference for you people here. All right, guys. So let's see the next part of our discussion. So what is meant by object standardization? Now, typically, what happens is whenever you are having your textual content, so there are some words or there are words available in your phrases which are not standard lexical dictionaries, right? They are not in the dictionaries. So what I'm saying is some acronyms, some hashtags, some words, some slangs. For example, this a slang called let's say LOL, right? So laugh out loud. So there are few of these slangs, few of the hashtags which will not be there in your dictionary, in the English dictionary. So we have to create our own standard dictionary for standardizing the textual content, right? So I'm going to give you an example with the program that's going to be a much more impactful part here. So what is meant by object standardization? So object standardization is all about, in case you have some of the words in your textual content which are not available in the dictionaries, so how you gonna process them? So I'm gonna write some lookup dictionary for us. So this is our dictionary, right? So there may be a key called BRB whose meaning is going to be right back, right? So this is a kind of a dictionary of key value pair which I'm creating. So these words are not available as a part of dictionary, right? But I'm creating my own dictionary. So this is my own dictionary, right? So I can just have this guy as dictionary. So there may be CB, which may be of meaning callback. Then sometimes we write awesome. So this is not exactly AWSM, it is awesome, right? So I'm creating my own dictionary. So for example, we use this term LOL. So let's say laugh out loud, right? So there are more of these, but I'm considering only this much of it, right? So this is our dictionary, right? It's not available in the part of your dictionary. So in the object standardization, what I'm gonna do is, if there is a sentence, right? For example, there is let's say a text which says, "Awesome you are. Call back me soon." Right? So there is a sentence. Now we would like to do text pre-processing. We don't know what is this CB. We don't know what is this awesome. These are even neither stop words, and stemming and lemmatization cannot work on them. So the first two approaches to text pre-process is not gonna work for us. So we're gonna deal with it. In order to deal with it, you need to substitute awesome with awesome word and CB with callback. So let's see how we can do that. So I'm gonna come here and say define object standardization. So the object standardization function, we're gonna take the input as text and we're gonna write some program here. So first of all, let us get all the words from your text. So this is very basic. You can say text.split. You will get all the words. And I'm gonna create one dictionary here, right? And this dictionary is basically going to be substituted words. So it's gonna be an empty dictionary to begin with. So for word in words, so guys, I'm just going to come up and do a lookup here. So if word in your dictionary, if the word is available in your dictionary, so I hope this is clear, right? So we are going to come up and see in case the word is available in your dictionary. So this is not basically the word, right? These are the word, but this is kind of key for us, right? This is key value pair. Dictionary is a key value pair. So in the substituted words, I'm going to append what? Your dictionary of that word, right? So if the word is AWSM, and if I get this AWSM in the dictionary, I'm going to get the value awesome and append it to my substituted words. So can I get an acknowledgement from all of you? So I'm gonna come up here and say text becomes your substituted words dot, or let's say this is going to be a space dot join all the substituted words, and let me return back the text. So guys, one small change here. So this is going to be the word which I will get. I will not directly append, right? So what I'm gonna do is I'm just gonna append it outside the loop so that all other words can also be appended. So I'll not append it right away here. So once this we come out of this if, so here I'm gonna append this word here. All right. So let's come here and say print me object standardization. I'll execute the function directly and pass this text. Let's run this program here. So stemming and lemmatization takes time. Okay, so just let me get back to some thing went here and there. Let me check what we did. Okay, so my bad, guys. So I'll just give me a moment. Let me now run this code. So this will take time, right? So this stemmatization and stemming and lemmatization is going to be a bit of more time. So guys, can I get a smiley from all of you? So awesome you are. Call back me soon. So I think this is very well substituted. So you did understand what is meant by text pre-processing, and I think this is not a challenge for anyone till now. And I hope you are enjoying this session at the same time. The next is parts of speech tagging. Guys, in parts of speech tagging, what we do is we have some sentences, and in the sentence, what is a noun, what is a verb. So exactly, Shashi, exactly. This is the example of autocorrection at the same time. So guys, in the parts of speech tagging, right? So we are going to come up and understand that in the sentence you have words, and some may be nouns, some may be verbs, adjectives, adverbs. So grammatical part of your text has to be converted. So POS or parts of speech will have certain tags associated. So you can find this list over your NLTK. Now, for example, for adjective, there will be JJ. For IN, it means it's a preposition or subordinating conjunction. So VB, it's a verb, right? WRB, WH adverb. So it's like your entire sentence can be represented with the tags, right? And then means noun. So let us see how you can actually tag your sentence with the help of POS tags. So this is going to be POS tags for us. So POS tags means part of speech tags. So in the POS tags, I'm gonna use my NLTK again. So you're gonna say import from NLTK. We're gonna import word tokenized and the POS tag. So guys, these are the two modules which we are going to come up and implement. Let us write the text. So we're going to write text. Stay safe, be at home, learn well, and code regularly. Right. So this is one of the sentence, right? So let us say that this is a sentence for us. And what I'm gonna do is I'm gonna say tokens is going to be your word underscore tokenize the sentence. So your NLTK is going to give you this kind of, you can say, a small function, right, with the help of which you can convert your sentence into tokens. So I'm gonna print these tokens here so that we understand what are tokens, right? And next part of it is to implement the POS tags. So I'm gonna say print me POS tag for every token. So it's very easy for us to understand how you can tag your words in your sentences. Let's run the program here. So what you see is your tokenization process converted your sentences into tokens. So it's a kind of a split function for us. But when we were trying to come up and do this POS tagging, it says stay is NNP. So what is NNP for us, right? So guys, over here, if you see, NNP is a proper noun or a singular. I hope you understood the meaning out of it, right? So with the POS tags, parts of speech tags, we are very easily able to understand what is this sentence all about. So and is coming as CC for us. So can I get a smiley from all of you? What are POS tags in our program? Wonderful, guys, wonderful. So now let me write this another program called session 52A. So what I'm gonna do is I'm gonna use NLTK and do some pre-processing on this Google About page, right? And we'll understand the frequency of some important words on this web page, right? So what I'm saying is I'm gonna implement a word counter for this web page. Let me come up and write some small program here. So let us come and say tokens. So this is till now I hope clear to everyone, right? This response.text. So I'm gonna say soup is an object of beautiful soup, and you're gonna come up and process this response.text. So the parser is going to be html.parser, right? So you're gonna parse the HTML content here. But what I'm gonna do is I'm gonna just make it as a basic soup.text. So guys, if you want, you can even come and do some parsing in case needed, right? But as of now, we are not doing any parsing. We are just considering the every text. Next is tokenization. So for tokenization, I'm just going to use my own list comprehension. So if you want, you can use your NLTK. So token for token in your text dot split. So I think this is how you will be able to get the tokens from your text, right? You get all the words, basically everything in your text, you get that. So if you want to print out the tokens, you can print out the tokens, right? But this is nothing but this is the same response which you are printing basically in the form of tokens as a list. Let us say from NLTK dot corpus. So corpus is basically a collection of words or sentences, but is a module here in NLTK. I'm importing stop words. So I'm going to eliminate the stop words basically in my tokens, right? So I want to eliminate the stop words in my tokens, and I have got this guy. So let's say st reference, stop word reference. Okay, I think we have a query here. No query, right? So let's say there is a stop word reference, which is going to be your stop words dot words, and these words should be considered as English stop words. Now I'm going to write another list of tokens called temporary tokens, or this can be tokens without stop word. So first of all, I'll just do a copy of data from tokens into your tokens without stop words. So guys, what I'm doing is I'm having this list of tokens. From this list of tokens, I am creating a new list, tokens without stop words. So initially, this list of tokens and tokens without stop words is of same size, right? So they contain both of them contains the same data. Now I'll write a list for token. In the tokens, if your token in your, so even more easier context here, in stop words dot words of English. So in case any token is available in this English vocab stop words, which is a collection created by NLTK, right? So we're gonna skip that guy, right? So in this tokens without stop words, I'm gonna remove that particular token. So this is how I'm doing my uh, you can say textual pre-processing. I'm removing the stop words from the tokens. Guys, can I get a smiley from all of you? So this was tokenization. So first of all, you need to do tokenization. So thereafter, you need to do your pre-processing. This is what I'm doing as my text pre-processing. I have not created my own list of stop words. I'm using the list of stop words available in your uh, NLTK. So once we are done with this, right, I'm going to come here and say there is a frequency which is your, so let us import NLTK at the same time. And this also I'm going to take up above. All right. So frequency is going to be your NLTK dot frequency distribution on the tokens without the stop words. So frequency distribution is going to give me the frequency of each and every word coming up in your tokens. So let us come here and say your frequency dot plot the first 10 words, the first 10 words available in your tokens who are used the most. So let me now run this program. All right, guys. So what you see is, so these two brackets, they are used a lot on the Google web page, right? So at the red media screen visible. So these are some of the words which are being used the most in the web page. So I hope this is clear to everyone at the same time. So let us print the 20 words, right? So you can analyze your frequency of tokens on the web pages being used. This I hope is clear to everyone. A smiley waited from all of you guys. So we got query from Shashi sir, what can be the application? So Shashi, let's see what is the application over here for the program which we have done, right? Frequency distribution. I'm gonna search for this Auribises here, and here we have these reviews coming in. So guys, what you see is experience is 42, teacher is 25, training is 22, skills is 15, environment, mentor, Android, concept, internship, right? So we are kind of implementing the same. Can I get a smiley from all of you? I hope you can recall we even did this small assignment in our previous discussions. All right, so in the text pre-processing, Shimpa, what we are doing is we are having these list of tokens. So if any token is found as a stop word, in the stop words of NLTK, we remove it from this tokens without stop words. So you are maintaining two lists. One is original tokens, one is the tokens without stop words. So good to go, Shimpa. So guys, this is all for the day. I hope you enjoyed the session, right? So I'm going to give you a few more assignments over the WhatsApp group. So this will be all for the day. So thank you so very much. Have a wonderful time and happy coding, guys. So Shimpa, this is a list of stop words available in English through NLTK. All right. So we imported this stop words from NLTK. If you see here. Thank you, guys. Thank you so very much. Have a wonderful time ahead. Bye bye.